Okay, what we're going to be looking at now is rates of reactions. Okay, so some of you today have had your uh, cooking catering exam, and some of you have think that you have done very very well, which is really good. Congratulations, big up Chasey. That's my first shout out. Well, my second one. My first one was to a vegan. My second one's to Chasey. Now, anyway, so what we've got here is rates of reactions. Okay, and you got to think of catering. Okay, so that's one of the ways you can think of this. So the question is, how can you? So this is the way to think about rates of reaction. Is how can you quickly cook an onion? Okay, so you need to cook an onion, fry an onion. Oops, onion. For whatever reason, the question is, well, how can you do it? So scenario number one: are you gonna add the onion in whole? Or number two, in the same scenario, so here's your first choice: are you going to add in the whole onion? Oh, that's more right, whole onion. Or are you going to cut it into smaller pieces? What you're going to do to make it cook faster? So just think about that. And number two, the question is, are you going to cook it on slow heat or high heat? So it's going to be a hot saucepan or a cold saucepan if you want to cook it quickly. Now, of course, the answer is that you need to cut them into smaller pieces. Now the question is why does this help with what the heck is happening? Anyway, the question is, why does this help with increasing the rate of reaction? Because when you have smaller pieces, when you cut down something into smaller pieces, it has a larger surface area, and because of this, there's going to be more surface available for reactions to occur. More surface available for reaction to occur. Now here is, are you going to use it on a slow heat or a high heat? Of course the answer is to increase the rate of reaction. You're going to use high heat. Now with heat, what this is going to do, it's going to give the particles in the reaction a higher kinetic energy. Right, so it's going to have a lot more kinetic energy, which is brilliant because there's going to be more collisions, and as a result the rate of reaction will increase. So that's the first two things that you need to be aware of. Increasing the surface area. If you want to make the reaction faster, you're going to increase the surface area. If you want to increase the reaction further, you need to increase the temperature. So those are the first two things. The next thing is it's more of a science thing. Okay, it's more of a science thing. So the cooking analogy kind of runs out here unless somebody can correct me on that and think of a good analogy. I can't. The third thing is to do with concentration. Now, if you're reacting an acid or an alkali or any chemical, to make it react faster, you're going to want it to be more concentrated. So if you increase the concentration, then you're going to increase the rate of reaction. Okay, so I'm writing ROR because I'm lazy. So the question is, how can you increase the concentration? Now there's two words that you need to be aware of. Alright, so this is my tea, and here is my sugar, so I'm going to add my sugar. Now, what I could do, there's two words that you need to be aware of. Number one is solvent, and number two is solute. Now the way I remember the definition for each of these things is solute is the thing you add. So in this case, I'm adding the sugar, that's the solute. And therefore the solvent is the thing that you're adding it to. You're adding it to. So the sugar is the solute because that's the thing you are adding, and the solvent is the thing that you're adding it to, so it's the T in this case. So the question is, how can you increase the concentration of sugar in this in the tea? Well, obviously, isn't it? You need to add more sugar. So if you add more sugar, the concentration is going to increase. The amount of sugar per volume is going to increase. Now the other thing you could do is you could to make it so number one is increase the solute, the thing you're adding, or number two, you could decrease the solvent. So if you decrease the amount of tea, right, so take some tea away and then add a sugar, it's going to be more concentrated than if you add more tea and one sugar. So the question is, well, how does this work now? Because if you have more particles of acid or alkali or whatever it is, more particles in a concentrated solution, right, then what's going to happen is there's going to be more particles that will react within your reaction. Okay, so that's the third thing you need to be aware of, is increasing the concentration. That is going to help you to increase the rate of reaction. The last thing is to add a catalyst. Now, as you should all know from like C1, I think it is, a catalyst is a chemical that increases the rate of reaction. The rate of reaction without being used up. Okay, so if you have 5 grams of catalyst to begin with, at the end of the reaction you're still going to have 5 grams of catalyst because it doesn't get used up. However, what it does do is it speeds up the rate of reaction. Now you need to know a specific example of a catalyst, okay, and this is found in cars. Okay, so this catalyst is found in cars, and specifically it is called a catalytic converter. Catalytic converter. Now, I have heard stories in my area, unfortunately, and it's happened to a mate of mine actually, where people are cutting off catalytic converters from cars. They're cutting off catalytic converters. Unbelievable. Unbelievable. But the question is, why are they cutting off these catalytic converters? It's because the catalyst that they are made of is quite expensive. Now, the catalyst can be made from platinum, which is expensive, palladium, which is expensive, or rhodium, which is expensive. So these are the catalysts. So it can be made from platinum or palladium or rhodium. They're quite expensive, so people are robbing them from cars and selling them off. Unbelievable. Anyway, the question is, how does this work? Now, the catalytic converter takes its influence from nature. Okay, it takes its influence from the amazing nature around us. It has a honeycomb structure. So why is that important? Because a honeycomb structure, what that is going to do is it is going to increase the surface area of your catalyst, or of the catalytic converter. Increase the surface area of your catalytic converter. Number two, this means that there's going to be more area available for reactions to occur. And finally, number three, increase surface area, more area available, and so this is going to increase your rate of reactions. And the next thing is, so number one is the catalytic converter has a honeycomb structure, and number two, it has a catalyst which is going to increase the rate of reaction without it being used up itself. And that's it. The final question is, well, what does it do? So if you imagine this is my catalytic converter, I'm gonna write CC for catalytic converter. What happens is you're gonna have your harmful gases that are made during the combustion of your petrol or diesel, whatever. You're gonna have your carbon monoxide, so that's carbon monoxide, or your unburnt hydrocarbons, so your unburnt hydrocarbons. And what the catalytic converter is going to do is it's going to convert, that means change, hence the name, using the catalyst, using these catalysts here. It's going to convert these really harmful substances, so your carbon monoxide and your unburnt hydrocarbon, into carbon dioxide and I believe it's water. Yes, and water. So it's going to convert it into carbon dioxide and water. Now carbon dioxide, the problem with it is obviously it's a greenhouse gas, it's going to cause global warming. However, it's better to have carbon dioxide than toxic carbon monoxide, and it's better to have carbon dioxide than toxic unburnt hydrocarbons that could contain impurities, etc. So that's catalytic converters done. Brilliant. Also guys, one final thing is a lot of petrol cars in particular and diesel cars, what you have to do is you have to warm the car up, and that's so that there's a high temperature so that this process is efficient as well. So rate of reaction, just to write a summary on the 4 things that you need to know. Number one is my onions example, so you need to increase the surface area for an increase in reaction, increase surface area. Number 2, you need to increase the temperature. Number 3 is you can increase the concentration of the acid or alkali or chemical or whatever you want to call it. Increase the concentration. And number 4 is to use a catalyst. Right. Now guys, of course the opposite is true, isn't it? If you want to decrease the rate of reaction, decrease the speed at which your reaction is going, you will need to decrease the surface area, decrease the temperature, decrease the concentration, decrease, or don't use a catalyst. Okay, so does that make sense? Of course it does. Brilliant. Brilliante.